Co-grade orbit. So yeah, and the orbit is almost in the same plane as the planet, something like that. And for irregular satellites, they have a very random orbit that has that is highly eccentric and elliptical. And yeah, as you can see, that's the that random thing there is like the motion of an irregular satellite. And so now for the how the moon is formed. So there are a few theories, and all of them are possible ways for the moon to be formed. And firstly, it's the accretion theory, which states that moon forms in the same way as planets. They form at the same time as the planets are formed. They congregate from the matter surrounding the planet. And the second one is the fission theory, which states that when the parent planet is rotating very quickly, the moon can just come apart like a fission. And the next one is the capture theory, which is the gravity of the planet just kind of captures some masses moving close to the planet from outer space, and that mass just becomes the moon. And also and finally there's the impact theory, which is currently the most accepted theory for the formation of Earth's moon, which states that when a big enough body hits the parent planet, it just ejects some matter to form the moon. Yeah. And now we will be talking about some moons of the solar system.
Okay, so I will briefly introduce to you the moons of the most well-known moons of Mars and Jupiter. So for Mars, there are only two moons, which are Phobos and Deimos. So they are both discovered in 1877 by Esther Paul, and I think at the time he works in the Navy agency of USA. So Phobos is only 6,000 kilometers from Martian surface, and it's closer to its primary than any other known planetary moon. A primary refers to the object that the moon is orbiting around. So it orbits Mars even faster than Mars rotates. It's 7.5 hours per round. So if you are on Mars, you can actually see 2 times of the rise of Phobos each day. And since it rotates so fast, if you are on Mars, you can actually see rise from the east instead of the west. So it orbits 4 times faster than the other moon, and NASA describes it as a critical link between Moon and Mars exploration, because it is more economical and more convenient for people to land on it first before people explore Mars. So for Jupiter, there are 67 moons so far that people have observed, and there are 4 most well-known moons called Galilean moons, which can be observed from our telescope. Actually, then the first moon that I want to talk about is Europa, which is the smallest of the Galilean satellites, and it's the 6th closest moon to Jupiter. And on its surface, it's covered by silicate rock and water ice crust. So it's highly probable that there may be extraterrestrial life on it. So that's what scientists are quite eager to find out. And the other moon is called Io, and it's the innermost of the 4 Galilean moons. It's the driest known object in the solar system, with over 400 active volcanoes on its surface. So the reason for its active volcanism is because of another mechanism called tidal heating, which is the constant change in the shape of the moon due to differences in gravitational force. So imagine Io is in the innermost side of the Jupiter, and it's half of it is attracted to the Jupiter due to Jupiter's gravitational field, and the other half is attracted to the other Galilean moons. So in this process, friction is induced in the core of this moon, and which results in heating. So that's the reason why Io is so has such active volcanism. And it's covered by sulfur silicate and sulfur dioxide frost, which can be expected because they are the products of the volcanism, and this contributes to the colorful appearance of Io. For example, sulfur contributes to the yellow and greenish yellow color in the tropical area of the Io, and silicate contributes to the white and gray color in other areas. And what is interesting is that in the north and south poles of Io, due to radiation, you guys actually take chemistry or take chemistry, right? So you should have known that the basic structure of sulfur in standard conditions is S8. So it's a loop shape. It is like a loop constructed by 8 sulfur atoms. So due to heavy radiation, this loop is heavily damaged, and so it contributes to the red color in the north and south pole of Io. And the next one is Ganymede. It's the largest moon in the solar system, and the only moon known to have a magnetosphere. And there may be an internal ocean which may contain more water than the Earth. So it is also a moon that might contain extraterrestrial life. And the last one of the Galilean moons is Callisto, and it's the second largest moon of Jupiter, and the third largest moon in the whole solar system. It's tidally locked, which means it's like the moon of the Earth. Only one side faces the primary, and it's the oldest and most heavily cratered surface in the solar system. And it is thought to be formed by the gas and dust that surrounded Jupiter when Jupiter was first formed. And there is also likely presence of ocean. However, it has less favorable conditions for life to exist. But it's the most suitable place for a human base to be constructed to explore the Jovian system, because it has relatively less radiation than the other moons, and it's the closest. It's one of the closest moons to the Jupiter.
Okay, so now I will be talking about the Saturn's moons. So Saturn also have a lot of moons like Jupiter, but fine. Saturn also have a lot of moons like Jupiter. So I'll just be talking about the largest and the most interesting fields. And the most prominent moon is Titan, which is the largest moon of Saturn, and it's also the second largest moon in the solar system. So it's like almost as big as Mars, and it's interesting because it is the only moon in the solar system that has a dense atmosphere and with clouds. And so NASA has said that in many aspects, Saturn's largest moon, Titan, is actually like one of the most Earth-like planets in solar system. And it has a unique composition, like it has liquid methane lakes all over its surface, and methane is an organic compound, so this creates the possibility for life. And like the abundance of methane and ethane means that like there might be a lot of extremophiles who survive on like this kind of methane and ethane, which may take the role of like water in the context of Earth. The second moon is I'm not quite sure how to pronounce this. It's like Enceladus, which is also quite an interesting moon. It isn't particularly big, but it's interesting because it has like hydrothermal vents that spews water vapor and ice particles instead of like the traditional hot steam that we normally associate with hydrothermal vents. And this is because the moon is heated by the kind of like tidal mechanism that is quite similar to the IO of the Galilean moons. And these water vapors actually rush out to a distance 3 times the radius of the moon. Yeah, and it also has a global ocean underneath its surface, covering the whole planet, which also raises the possibility of life. And finally, another interesting moon of Saturn is Hyperion, which is the largest irregular and non-spherical moon of Saturn and also of the solar system. And as you can see, it doesn't really look like a moon. It looks more like an asteroid. And yeah, as you can see, it's potato-shaped. And yeah, it's like it has a lot of impact craters, which makes it look kind of like a sponge. And that's all. Thank you.